Looking at a question here that involves the sine law, but we're going to find out that sometimes there's more than one answer to a sine law question. So let's zoom in and take a look at this one here. So we're given a triangle ABC with an angle B of 48, side length C of 11, and side B of 9. And I'm going to just draw a rough sketch of what that looks like. So I'm just going to draw a random triangle, try to faithfully represent the angles that I have. Try that again. So I'm going to have A and B over here and C over here. This is 48. And I know that side B is 9. Actually, let me draw that a little bit different. Just going to shrink this up a little bit. You'll see why later. Okay, so there's C, and then I have side C, which is 11, okay? And I want to solve for the value of C using my sine law. So let's go down here and write it out. So I have sine of C over 11 equals sine of 48 over 9. And if I do the math, sine C is equal to 11 times sine 48 divided by 9. That will give me 0.9082, so roughly. And if I do the inverse, okay, angle C is going to be approximately 65 degrees. So let me go back to my diagram. I'm going to write in here 65 degrees, and that kind of looks like 65. I mean, it's definitely bigger than B by the looks of it, and it looks like it works. But are there other answers to this? And we're going to use the CAST rule to figure that out. Well, we know that when C is 65, we get a value. But what if we have another value? And according to the CAST rule, we do. Because if we use a reference angle of 65, then 115 degrees is going to be our second value that gives, a true value to sine of 65, or an identical value to sine of 65. So sine of 115, same thing. If you don't believe it, plug it into your calculator and you'll find out. So we have two cases. The first one is kind of intuitive. The second one, well, we're going to explore that a little bit. But in the first case, if I have 65 and I have angle B is equal to 48, well, angle A is going to be 180 minus 48 minus 65, which is going to give us, what do we get here? 67. 67 degrees. And that kind of makes sense. Not 65, 67 degrees. And to solve for, side A, this is 9, we just use our sine law again and solve. Now, what about in the second case? Well, again, angle B is fixed at 48 degrees. Angle A is going to be 180 minus 115 minus 65, which gives us 17 degrees. Okay, well, how is that possible? I mean, I don't see a 17 degrees in our picture. Let's take a look. I'm going to copy this. And I'm going to paste this over here. Make it a little bit bigger. And zoom in. So we have 115 degrees. So C can also be equal to 115. And the question is, well, how is that? Well, if we go back to the original question, we didn't have this. We didn't have this. The only information we were given is what you see there on the page. But who says side B from A to C has to go over there? What if it went to here? You see? You've met all the conditions of the original question. This is an isosceles, really. You still have the 48, you still have the 11, you still have the 9, But now, okay, angle C over here is 115 degrees. Angle A, which is over here, okay, remember we're focusing on this triangle, is going to be 17 degrees. And side A is going to be smaller, obviously, than, what we had originally over here. So this is why it's called the ambiguous case, because we have two possible triangles. One is, the oblique triangle with the large 115 degrees, and the other one is the acute triangle where you have, all sides less than 90, but, looks like it's a bigger one overall. Okay, so this is the ambiguous case of the sine law. It doesn't always occur. There are cases when it fails, and we'll see that in the next example.